Hello everyone, this is Zach Stockbridge. This video is going to be a quick look at how to get a really well fine-tuned polar alignment using your telescope and a camera while looking at the sun. This is a great procedure for those situations where you want a really good polar alignment, but you can't set your equipment up overnight, get a good alignment on the North Star, and then leave your gear out for use the next day. I already have the telescope set up. The mount is nice and level, and the telescope is pointed north, but I have adjusted for magnetic declination. So don't set your compass at 360 degrees. First, figure out what your magnetic declination is for your location, and then adjust accordingly. Once you have that, and the sun is on the screen, now we're ready to move into fine tuning. There are two steps to this process. First, we're going to check our camera rotation, and then we're going to really dial in and fine tune the alignment. Now, you'll notice that I've got some clouds moving across the face of the sun here. That's why my exposure is set at 2.4 milliseconds on the camera, which is definitely higher than what I would normally use. But that's okay. That doesn't really matter for what I'm trying to demonstrate today. First thing we need to do is check the camera alignment, and we're going to use the reticule tool for everything up here. We'll come back to zoom in a second, but for the reticule, we're going to start with the circle reticule. Now you'll notice that wherever I click on the screen, it's going to reposition the center of the reticule according to where I click. To check our camera rotation, we're going to put the reticule right along the bottom of the sun there. So we've got that red line extending horizontally all the way. And now we're going to use the controls on the telescope mount to move the sun from side to side in our image. And the goal is we want the bottom of the sun to stay right along that line the entire way out. So moving it across, that's pretty good. If you zoom in, you can see that I've drifted downward a little bit. Normally, I would try and fiddle with that a little bit more and get a touch better, but for today's purposes, just demonstrating, that's pretty good. If you also want to check and see how well you do along the vertical line, you can. Sorry, these telescope controls are kind of hard off of the smartphone, so I jogged a little sideways there, but you get the idea. In order to move on to really fine-tuning our alignment, we're going to go back. We're going to get the sun centered on the image. So I'm going to use the crosshairs to pinpoint the center of the sensor, and then we'll move the sun so that it's more or less centered on that spot. All right, not perfect, but pretty close. We're going to go to the reticule tool one last time, and we're going to use the multi-reticule tool. Now, here's the great thing about this. You get a couple of reticules at the same time. Let me kind of zoom into 150% here just to make it easier to see. Take a look there. You get pixel coordinates for the center of each crosshair. We're going to take the red, I'm going to place that right along the side of the sun's limb. Make a note of those pixel coordinates. I'm going to lock this one so I don't accidentally change it. Now we're going to do the same thing using the yellow reticule. We're going to place it right along the bottom, lock it. Note those coordinates. So for the red, we need to look at the X coordinate. For the yellow, we need to look at the Y coordinate. Now what we're going to do is we're going to wait for a couple of minutes. Set your timer for 1 minute or 2 minutes, whatever kind of time period you have, and we're going to be able to look and do the math on exactly how many pixels per minute of drift we have. So I'm going to pause this recording. I'll come back in 2 minutes and let's see how we did. We're back. It's been about 2 minutes. Let's check and see what our drift is. We're going to start with the side to side drift. Notice that our red, we've gone from an X coordinate of, call it 1905 to what's exactly 10 pixels of drift in what ended up being closer to 3 minutes. So we're definitely under 5 pixels per minute of drift from side to side. That's honestly a great alignment. I'm not going to try and fiddle with it anymore. If I was going to adjust to correct for horizontal drift, you do that by changing the altitude of your telescope. So I'd be using this guy. Now we're going to go back. Let's take a look at how our image drifted in the up-down direction. Unlock the yellow, say we can adjust that. We've gone from a Y coordinate of 1392 to, whoops, got to use the slider to bump down a little bit so I can see that. All right, about 28 pixels in, call it 3 minutes or so. We're under 10 pixels per minute drift. which is okay, but it's not great. If I was going to adjust that, which I will as soon as the video is done here, we're going to adjust and we're going to rotate the mount along its azimuth, and you'll do that according to the chart that I'm slapping up here on the screen. I'm going to go ahead and I'm going to spin the azimuth dial for the telescope mount and then reposition and try and get this to be a little bit less drift. And then you simply continue to repeat this process. The goal is to get our drift down as little as possible. If you get 0 to 2 pixels of drift, you are doing outstanding.